So I'll talk about the integrable structures of quantum Boussinesq hierarchy. This work has been done with Sujay, Sangeeta, and others from MSc and Roberto from Anderson Torino. We know that two-dimensional conformal conformal field theories with only the Virasoro algebra consist infinitely conserved charges which commute with each other. They are known as the quantum KdV charges. Here I have written the first few quantum KdV charges. We want to generalize this for W3 algebra. Now, why we want to study this? We want to study a generalized partition function, which is written in terms of the charges, and you turn on stochastics for each charges. Boussinesq and collaborators, they have studies for this KdV that heavily depends on Melani's computation of the thermal correlates for the KdV hierarchy, and we want to study this for the W3 hierarchy. Now, in mid-80s, BSZ studied the KdV hierarchy in quite detail. They have computed the eigenvalues of the charges on a highest wave state, and here here the first few eigenvalues, and the KdV current is defined as this, where current is J and the charge is Q. Using the thermal correlators of the current or the charges and the eigenvalues, you can fix fix the currents if you take a general answer and compute compute the thermal correlator, and you match with the eigenvalue, and you can fix the unknown coefficient. And thermal correlator we compute using the Zoo recursion relation, and this has been done by Melani et al. Now, for the W3 hierarchy, we don't have the eigenvalues, so what we use is ODM correspondence. Here, this is the ODE corresponding to the Boussinesq hierarchy, and here we study the WKB expansion of this ODE, and the period integral of the something called S will consist it's proportional to the charges, and here the M and L are the some variable in the differential equation, and the map with CFT data is given by this relation. So we have computed the eigenvalues of the charges where delta 2 and delta 3 are given by this equation, and the first few four eigenvalues matches with Boussinesq's known charges for the Boussinesq hierarchy. And we have computed the thermal correlator of the charges as I have discussed below, and the thermal correlator is defined as this, where we have computed this with the Zoo recursion relation. Now, if you take a general answer of the KdV, the Boussinesq hierarchy, where there are three unknown coefficients, if you do the similar business, compute the thermal correlators and compute the match with the charges, and you can fix the unknown coefficient. By doing the similar analysis, we have for the higher order charges, we could fix this up to an unknown coefficient, but the thermal correlator of this particular object vanishes uniquely. To fix this, we have computed the higher order eigenvalues in the highest excited states, and we have computed 2-point thermal correlators, and using that, we have fixed the unknown coefficients. So the results are the following. We have computed the charge, computed the eigenvalues of the Boussinesq charges in the ground state, first excited state, and the second excited state. We have fixed 3 new currents, which is J8, J9, and J11, and we have computed thermal correlates of the charges exactly up to I10. Now, what we want to do, as I have discussed earlier, we have to study the generalized partition function. In the last central charge needed of the conformal field theory, it will be also interesting to study the modular transformation property of the general Gibbs ensemble. As a first step, we take only one charge, and we are trying to construct the modular properties of this object, which is also the full character of the W3 algebra. Thank you.